Hello everyone, I hope you're all fine. Now in this video we are simply going to continue and do our question 3 here, okay, November 2023 paper. So now this is a VPM, vertical projectile motion topic. It's talking about the vertical movement of objects through on the air. So a ball of mass 0.5 kg, this is our ball here, it is thrown vertically upwards. So as you can see, it is what? Thrown vertical upwards. So it was thrown with the vertical upward. This is what? Certain velocity. Okay, from the top edge of a building, which is 15.3 meters high. The ball reaches a maximum height of 5.89. So this is the maximum height, and you know that at the maximum height, the velocity is simply equals to 0. The final velocity is equals to 0, okay, above the top of the building. The ball strikes the ground and bounces vertical upwards. So this is where it is striking the ground, and you can even see that this is what the final velocity when it reaches the ground, okay. Then it is now bouncing upwards vertically again, reaching a maximum height at point P, okay, as shown in the diagram below. So now we can see that, okay, this is the first point whereby it was projected from, and then it went upwards, then here it returned to the ground, and then here what did it do? It bounced off, and you can see that this is the very same point of projection. So this is a case whereby you project a ball upwards, and then that ball passes the point of projection, okay, then it bounced again. 3.1 says define the term free fall. Free fall is simply the motion under which the force the only force acting is the force of gravity, or you can say motion under the influence of gravity only, okay. That's how it is. So now, using only equations of motion, calculate the speed at which the ball was projected upwards. So they are simply looking for the initial velocity, okay. So what do you have now? You're simply gonna start, okay. They want the initial velocity. So what they're gonna do now, this is what 3.2. You are gonna check, do we have the VI? No, it is the one that they want, okay. Now, because now you'll have to use what? Equations of motion. Do you have the final velocity? Yes, I do have it. It is equals to 0, because you know that at the maximum height where your ball reaches and then goes back down, the final velocity is equals to 0, okay. And then do you have what do you have again? The acceleration. Obviously it is equals to what? Negative 9.8 meters per square seconds. This was is meters per second. Then what do you have again? Oh, I was given the delta y, which is the what? The height, which is equals to 5.89 meters. Do I have the time? No, I do not have the time. Do I have the what is required again? So there's nothing there. So I have VF, I want VI, I have this, I have that. So it simply means that I'm gonna use this formula. So I'm gonna use VF squared equals to VI squared plus 2a delta y, okay. So VF squared obviously is equals to 0. They are looking for VI, then plus 2 negative 9.8. Then the distance, the what you call the height. What is the height? It is simply what 5.89. Then now what do I have? I simply have to multiply these things, okay. So you can simply take out your calculator and multiply them. So meaning that I'll have to take them to the other side. So what is 2 9.8 and then 5.89? 115.444. So 115.444 equals to VI squared. Then therefore when you do the square root, the answer is simply 10.74 meters per second. Can you see it? So this is the final answer there, okay. This is the velocity with which the ball was projected upwards with. So now let's check something now. This one now, they are saying that after the collision with the ground, the ball leaves the ground with what? With a speed of 11.92 meters per second, okay. So now check something. This is where the ball bounced, okay. So now from the illustrations that you will have, now they are simply checking what you call telling us that it left the ground with what? That 11,92. But now the question says they want the amount of kinetic energy lost, meaning that they're simply looking for what? For the change in EK, okay, during the collision with the ground. So now the first thing first that you're gonna start, we are simply gonna start calculating the final ground with which the ball moved from this point here, the maximum height, up to this point here. Okay, that's what we are simply going to do, because we simply have to start finding the velocity there. Okay, because if we don't do that, we won't find the correct thing there. Okay, so now we are going to start there. So let's go. Where's my paper? Here it is. So now we are going to use the very same formula. Vf squared equals to Vi squared plus 2a delta y. So now we are simply going to start doing what? Calculating what? The final velocity now, with which the ball struck the ground with when it was reaching this place there. Okay, so now we are simply looking for our Vf. So Vf squared equals to, now I just calculated my Vi, right? So I am allowed to do what? To say 10,74 squared plus 2 negative 9,8. But now check something here. Now I just told you that you can even calculate from here to here, ne? So now I'm thinking, since I included the Vi here, so check something. I am gonna use what? I am gonna use this height 15,3. Why am I using it? You simply know that, guys, if the ball goes from here to here and it comes back here, it is the very same thing here, so they basically cancel out. Okay, so now I am allowed to use the what? This height and this what? Velocity of 10,74 meters per second. And then now on your side, you can simply calculate the final velocity from this point to this point, meaning that the height is going to be 15,3 plus 5,89 on your calculations. And then now the initial velocity, it is now gonna be what? 0, because this is where the ball starts to return to the ground. Okay, it is now losing its power, so it is just going back downwards. It was not projected downwards, it just lost its power, so it is the same as being thrown downwards. So that is why I'm saying that you can do the alternative method by making the Vi equals to 0. Okay, same formula, but where there is Vi you put 0, where there is the delta y you put what? 21,19. But now here I'm gonna put what? 15,3, but it is gonna be what? A negative 15,3, because now the ball is now going where? Downwards. It's a downwards movement. So Vf squared, it is gonna be equals to 10,74 squared and then plus 2 times negative 9,8 and then negative 15,3, and then let's find the square root. So my answer is simply 20,37, which is equals to, oh, I forgot that one. So Vf, it is equals to 20,38. Here I think I got 455, something. So our final answer is simply 20,38 meters per second. Okay, now this is what we have now. Since we found the final velocity, now we can calculate what? The change in EK. Okay, so now what is the formula for kinetic energy? So now it is simply going to be what? Change in EK equals to EK final minus EK initial. Okay, so now I can write half m and factor out the what we call the half m, because now it is the same mass, so I'm allowed to put it like that: Vf squared minus Vi squared. So 0,5 here. Now check the tricky part here. I want to show you something now. Now we want what? The final velocity and the initial velocity. Okay, so the initial velocity, check something. The ball came here, ne, with what? 20,38 before it struck the ground. This is the velocity that it came with here. So it is simply like this. Maybe you can put it like this. So from this height to this ground, the ball came with 20,38 meters per second. But now we were told that it leaves the ground with the speed of 11,92. So this one can be our what? Vi. This one would be what? Vf. Because this is the initial velocity that the ball came with before it struck the ground, and then the final velocity that it left the ground with. Okay, meaning that our final velocity is simply 11,92. Make sure that you understand the difference there. Okay, because you're simply told that the ball leaves the ground with 11,92 meters per second. But check something. It strikes the ground with 20,38 and then leaves the ground with what? 11,92. Meaning that 11,92 is the what? Final velocity. So our final velocity is going to be 11,92 squared minus what? 20,38 squared. Okay, so now as you know that this that is going to be our answer. The answer is simply going to be what? Negative 68,31 joules. Okay, that is how the answer is going to be. I hope you understood. So both of them are squared there, so that is the answer. So now the next question, they're simply looking for what? The time taken for the ball to reach point P after leaving the ground. So now they're simply looking for the time that it took for the ball to go back to point P. Okay, so now let's check something here. Point P is here. So now we also know the velocities. Now we simply have to calculate what? The time there, because there's nothing much that you can do. Okay, so now we know that the initial velocity there is what? Is 11,92, and then now we simply have to calculate the time. Okay, let's go. So which formula can we use there? We know that our acceleration is simply negative 9,8. And then now, what is our initial velocity now? Remember, now I'm taking upwards as positive. So now my final velocity is gonna be what? 0. Why am I saying that? At this point P, it is where it ended. So this is the final velocity. Then when it leaves the ground, it was 11,92. So this is the best formula. Vf equals to Vi plus A delta T. What is Vf? 0, because at P it was the maximum height that it reached from the ground. The Vi, it is what? 11,92 plus negative 9,8 delta T. So this side of 9,8 delta T equals to 11,92. Therefore, my delta T is simply equals to what? 1,22 seconds then. Is it fine? I hope you understood there. Now let's conclude and continue with the other question. Now, this is a velocity time graph now of the whole scenario. The velocity time graph for the motion of the ball from instant. It is projected when it is projected upwards from the top edge of a building until the time it reaches point P shown below. So now, this is where the graph starts, meaning that this is the what? Initial velocity, and we got our initial velocity as what? 10,74. Okay, then now it went down, and then here, this is your what? Your maximum height. Okay, make sure that on the velocity time graph, the x-axis, it is the what? The maximum height. Then what happened? It passed the point of projection, maybe somewhere here, and then now this is the point whereby what? It struck the ground. So now, meaning that the velocity for this part, it is simply that one, and it's going to k, meaning that the velocity here, it is the what? It is the one that it left the ground with, which is 11,92. Can you see it? Because this is when it reached the ground, and then what did it do? It left the ground and went to point P. You see, went upwards. So meaning that this way it reached what? Point P. So K, it is simply 11,92 meters per second. L, it is 10,74 meters per second. Okay, I hope so far so good. So now let's finish up. What is the last one now? The difference in time. T2 minus t1. So now let's interpret this one now. This is when it reached the what you call the maximum height as it was going where to point P. So meaning that t2 minus t1, remember the time we calculated here, time taken for the ball to reach point P after leaving the ground, we got what it is what 1,22. Okay, so the answer is simply gonna be what 1,22 because there is at some point where by the time was equals to what to 0. Okay, that's how it is. I hope you understood, guys. Thank you very much for the video. I hope you understood. Then yes.